Oh, snap, it's time to grab another rational function. And yes, Riverdog Jenny is still here, but she fell asleep in class. Didn't you, Jenny? Yeah. Okay. So we're going to do this one without her. We'll check in, though. We'll check in. All right. First things first, we're going to factor. And guess what? We have a lead coefficient because I was thinking like, man, should we have a lead coefficient? Heck yeah, we should. So we're going to do a little bit of factoring here. So for those of you that don't remember rainbow method, here we go. So we got 2x squared minus 5x minus 3. Got to multiply those two. It's negative 6. We want to add the negative 5. So that's going to be negative 6 and positive 1. That's what I'm talking about. So we got 2x squared minus 6x plus 1x minus 3. Then we are going to group the first two and the last two. Now we have GCF action. So we got 2x. We have x minus 3. And the other one, since there's nothing that can come out, we're just going to take out a 1 as a placeholder. We have x minus 3. So we got 2x plus 1 and x minus 3. Remember when that was just your math problem that you had to do and you're like, oh, I hate factoring with leading coefficient. Now we got a whole bunch of other stuff to do, and that's going to be awesome. All right. So, Katoa. We got 2x plus 1 and x minus 3 in my numerator. Good to go there. Denominator, that's going to factor into, well, it multiplies to 3 and adds to negative 4, x minus 3 and x minus 1. We are factored. We're ready to rock. We're going to get going on our domain. So let's do the domain now. Domain, denominator. Domain, denominator. What's going to make that denominator 0? Got to tell you that we can't equal that. You know what I'm saying? 3 is going to make that denominator 0. Can't equal 3. Otherwise, it's going to be undefined. We're going to be divided by 0. All right. How about 1? If I plugged 1 in, I'd get 0 times negative 2 in my denominator, but that's going to be 0. I can't divide by 0. So 3 and 1 are my no-nos, kids. They're my no-nos when it comes to this function here. So those are my domain restrictions. Next up, we got holes. All right. All righty. Holes are what cancels. So the x minus 3 is cancel. Now I'm going to take that x minus 3. I'm going to set it equal to 0. And I get x equals 3. So that is my x coordinate for the hole. Now I'm going to rewrite this function fully simplified here, since I've got everything canceled that I could, and I've got 2x plus 1 over x minus 1. Now we can work with this one. It's going to be a little bit easier to find other values with a more simplified function. So how am I going to get my y coordinate? Well, if I have my x coordinate here, I can take this 3 and I can plug it in to the function that's been simplified. 2 times 3 plus 1 divided by, 3. There we go, eraser. 3 minus 1. So that gives me, we got 6 plus 1 is 7 divided by 2. Ugh, that's terrible, but whatever. 7 divided by 2, 3.5, right? If we do that in our cabeza. All righty, I like that. That's wonderful. That's fantastic. Next up, we got vertical asymptotes. Vertical asymptote. That is whatever is left in my denominator. That's how I determine my vertical asymptote. So I would take the x minus 1, which is left in my denominator, set it equal to 0, and I'll get x equals positive 1. So my vertical asymptote is x equals positive 1. Beautiful. All right, we're just cruising through here. How about horizontal asymptote? Well, this time we have a different rule. So our other rule for horizontal asymptote is that if I have my degree in the numerator is the same, it's a little too big, over the same degree, okay? Then I'm going to look at my coefficients. So it's going to be y equals coefficient over coefficient. So for this one, if you look at my degrees in the original are both 2. That's same over same. Even in my simplified one, I have a degree of 1 and 1. It's the same over the same. So I'm going to look at my lead coefficient. Whether we look in the simplified or the original, it's going to be 2 over 1. See, 2 over 1. So my horizontal asymptote is going to be y equals 2 over 1, which is just y equals 2. All right. That's some good stuff. So we got all my asymptotes, holes, domain. Next up, x-intercepts and y-intercepts. All right, so x-intercept and y-intercept here. We got to, let's see. If I want my x-intercept, that's when y equals 0, right? So if I take 0 equals 2x plus 1 over x minus 1, really we only need to focus on our numerator. Because if I can get my numerator to be 0, 0 divided by anything is 0, as long as that anything is not 0. We don't want the denominator to be 0, right? Because otherwise it's undefined. So really, I'm just going to take a look at my numerator and set that equal to 0. So I'll have 0 equals 2x plus 1. If I subtract 1 and divide by 2, I'm going to get x equals negative 1/2. So my x-intercept is going to be negative 1/2, and my y-coordinate, of course, is 0. Well, when am I going to cross the y-axis? Okay, that's when x is going to be 0, right? So if I say, okay, well, I already know x is 0, how am I going to get my y? Well, if I want to get my y, I need to substitute in 0 for x. And I can do that in the original or in the final simplified one. Honestly, it's pretty easy to see from the original. If you remember back to polynomials and finding your y-intercept, when you plug in 0 for all your x's, they all go away except for your constant, your last term there. So really, I'm just looking at these two because my 2x squared, if I plug 0 in, it's gone. Same with the negative 5x, same with the x squared, the negative 4x. So we're looking at negative 3 over 3, which is just negative 1. The same would occur here in my simplified one. I have 1 divided by negative 1 because when I plug in 0 for x, I get 0 plus 1 over 0 minus 1. All right, so there we go. We're good to go on those. I think we're ready to graph, aren't we? Awesome. All right, so let's do it. Let's get our, our asymptotes in there first, right? I'm getting like jump the gun here. I want to get my asymptotes here. Okay, so vertical asymptote. I'm going to get a little bit bigger marker here so we can see them. So we have x equals 1. That's the vertical. All right. You can pop an arrow on that. I think I forgot that at one point. All right, and then let's get our other asymptote, our horizontal. We'll get the yellow one, make that a little bit bigger so we can see it. We got y equals 2 this time. All right. And then next up, we got our intercepts, right? Our x-intercept and our y-intercept. Cool. Let's do it. Negative 1/2, 0 would be my x-intercept. So negative 1/2, 0 is going to be right there. And then I got y would be 0, negative 1, which is going to be right there. Okay. Well, that paints a pretty clear picture as to where part of the graph is going to be. We also have the hole in the graph. So let's make sure we plot that. Don't want to forget that, man. All right. So I got 3. And then we said 7 over 2 is like 3.5. So that'd be 3.5. It's going to be right there. I accidentally did it before I made my circle. Hold on. There we go. There's a little orange guy that was bothering me. Okay. Boom. All right. I like it. So that is 3, 7 over 2, or 3.5. Now we have everything. And we actually know exactly where everything is, fortunately, because I have a couple points at the bottom left there, and I got a hole at the top right. I can just go ahead and connect all this stuff. All right. So we got to get close to the asymptote, never touching the asymptote. You'll find actually in the future that you can cross a horizontal asymptote, but it comes back to it. All right. Now my vertical asymptote, never going to touch it, never going to cross it. There we go. That's good stuff right there. Woo! Woo! Jenny, what you think about that? Are you really not impressed by that rational? I really thought you would have been going for it. All right. There we go. We got it all. Everything's down. That was awesome. You guys are awesome and fantastic. And have a wonderful day, America. Freedom, rock and roll, Costco. River Dog Jenny on the gram. See you later. Yo, Ro.